Okay, so like I was saying, if it's not one of these two, then you're, in any other case, you're just going to have to calculate the value of Gibbs free energy just with the equation itself. So let's go ahead and do the two examples. The example 13.7, we're almost done, on page 448. They give you this equation and then they say this is the delta H, this is the delta S, what is delta G at this temperature? Is it spontaneous or not? So this is the equation we have to use. They gave us the delta H, so we plug it in. They gave us the temp, we want to use the one in Kelvin, 805. And then the delta S, we just needed to make sure that our units matched. One was joules, one was kilojoules, so we just switched it to kilojoules, okay? And that's what they did right there. So we switched it and then we plugged it in. Now we go ahead and cancel our units. So we have this minus this gets us 4 kilojoules. So now we ask ourselves, is it spontaneous? So a positive answer when we're searching for G, remember you're gangsta, okay? If it's positive, can't do it, okay? Not spontaneous. So at this specific temperature, this reaction is not spontaneous. It will not happen, okay? Then they say, is there a temperature at which this reaction does become spontaneous? Yes, let's figure it out. So instead of searching for this, we want to know what temperature, okay? So we're just going to say this whole thing has to be less than 0, okay? So this is our formula. So we're going to plug in our numbers just like we did. This is our delta H. Now we're solving for T at what temperature does it become spontaneous? Less than 0, okay? So this is our delta S. So we're just going to use algebra and go ahead and undo this to solve for T. So I'm going to add this over here. That's going to cancel that. So let me just rewrite it. Moles K is less than 114.2 kilojoules per mole. All right, now, real quick, if you divide by a negative number with an inequality, it flips the inequality sign. Don't forget that. In this case, these actually both become positive, so we don't have to worry about it here. So just go ahead and divide both sides. Kilojoules per moles Kelvin. So T is less than, I cancel my moles and my kilojoules, I'm left with a Kelvin, and this ends up being 777. So this reaction, it will work in nature. It becomes spontaneous, or it becomes a negative number. That's what it means by less than 0. If it's negative, it can go. Okay, the very last thing we're going to do is we're going to find the delta G, Gibbs free energy, using it the easy way. We don't have to use the equation. Okay, so we did it with the equation at all other temps. Now this last one, it says, what is the delta G for the following reaction at 298 Kelvin? When it's 298 Kelvin, room temperature, we can just use the same thing we've been doing. The sum of the products minus the sum of the reactants. So they give you this equation and then they say, is it spontaneous? So we're going to go ahead and look at it. In order to find delta G, we're just going to take the products minus the reactants. So CaCl2, I have 1 mole. Here, let me write it up here really quick. CaS plus 2HCl aqueous CCl2, CaCl2, and that's a solid plus H2 in the gas. Okay, so let's go ahead and start here. I've got 1 mole of that, and this is where I can use my table, my last table here. If I look at my table, I will find it down here, and it's negative 750. Look for your units, kilojoules over moles, plus H2. Remember, same thing with this. When it's an element, it's just a big old 0. Subtract. Now we get to go over here. Calcium. Calcium is also just a 0. Plus, we've got 2 moles of HCl, aqueous. Go ahead and find it. Over here, negative 131 kilojoules per mole. Okay, so crunch this and crunch this. We're going to just take this minus this. That's going to get us negative 490 kilojoules because our moles cancel. Okay, if this is a negative number, okay, remember positive numbers mean nope, not spontaneous. Negative numbers mean spontaneous. Good. They don't go against the second law of thermodynamics. So this one is spontaneous only at that temperature. Okay? That's what they had said. Now, remember, the whole reason why we do this, Gibbs free energy, is we're taking into account the delta H, the change in energy, and the change in entropy, the disorder. So we're talking about the disorder and the change of the energy around the reaction together, okay? All of this is to say, does it go along with the second law of thermodynamics? Yes or no? If it does, it will occur naturally. If it doesn't, it will not, okay? So go ahead and do 13.11 and 13.12 on your own. And then for next week, go ahead and do the practice problems and the review problems, and we will go over those together.